Yeah, good morning to all of you. In this lecture, I am going to solve the examples which is based on the concept of electric potential. In previous lecture, I have already explained what is electric potential, what is its profile due to a single point charge, and I have also solved one examples in which a charge Q is placed at the corner of a square whose sides are A, and we have find out the potential due to the charge at two different corners. So in this example, I am going to explain if we have a profile of electric field. So for a given profile of electric field, how to obtain the electric potential expression. So we have example which is the electric field in a region. So this is example. The electric field in any region is given by E equal to A by x cube I, where A is any constant, x is a variable and I cap is a unit vector. So we know the electric field is a vector quantity, that is why we are expressing the profile of electric field in this term. So for this profile, find out what is the suitable dimension. Point A, what is the suitable dimension of A, and second, obtain the expression of potential. Obtain the expression of potential. So the whole question is divided into two parts. See, unit and dimension is a very important parameter in every section of or in every unit of physics. So that is why the first section we have to find out what is the dimension of this quantity A, which is unknown quantity. So we have information about E, we have information about X. So X is a dimension of, X is simply in length, it has dimension of length. So with the help of, so X is in meter or centimeter. So obtain what is the dimension of A and obtain the suitable expression of potential. So what is the information? So this questions gives the information that for a given profile of electric field, we can find out how to find out the potential profile. So let us deal it one by one. The first question, solution A. See, we know that we can add or subtract only those quantity whose dimensions are equal. So with this analogy, we can write, we have this is electric field which is A upon x cube I cap. So what is dimension? Dimension of or unit of what is suitable SI. Let me just, what is the suitable SI unit? SI unit of A. So once we know the unit, we can easily find out the dimension also. So unit of E, so this is E into X. So unit of E into X cube is simply equal to the unit of A. See, E is electric field, X is in meter or centimeter. So it has dimension of L cube. So unit of A is unit of E is electric field, which is Newton per coulomb, and it is meter cube. So unit of A, so A is basically unit of A is basically Newton meter cube per coulomb. And what is dimension? We can also find out the dimension. Means we can express these entity in terms of MLTA theta. We can express this entity in terms of MLT, basic dimension, meter, length, time, ampere, coulomb. So you can just fill this blank. So with the help of this, you know 1 Newton is kilogram meter per second square. So with the help of this, you can find out the dimension also. But in this question, we have to simply find out the suitable unit in SI system. So electric field, unit of electric field in SI, unit of this length in SI is meter cube. With the help of these two, we can easily find out the unit of A. Now come to the second part. So this is solution of B. Now we have to find out the expression of potential. So we know that the relation between the potential profile, in earlier lecture I have already discussed that potential is simply E dot dr or E dot dl. You can write it either E dot dl or E dot dr, where E is in I cap. So E is a vector, dr is also vector. So we have information about E, which is A upon x cube I cap, and what is dr? Dr is a again length vector, which is dx I cap dy j cap plus dz k cap. So we can express our length element, this is vector, in 3 dimensions. Now taking the dot product of E dot dr, so simply our E is only in I cap. So and dr is in I cap, j cap, k cap, in 3D situation. And we know the product rule. That I cap dot I cap is 1 and I cap dot j cap is 0. I cap unit vector k cap is 0. So simply E dot dr is simply A by x cube I cap. This is simply the dot product of 2 vector. E is electric field vector and dr is another vector. So this is simply the dot product of 2 vector whose outcome is here, which is dx I cap dy j cap and dz k cap. And we know only dot product of I dot I is 1, I dot I is 1, I dot j is 0, and again I dot product of I with k is again 0. So dot I will only give 1 and rest will give 0. So what we have? We have simply A by x cube dx I dot I, and rest will be I dot j is 0, I dot k is 0. So dot product of this term is I cap is only 1 correspond to I dot I, and 0 correspond to I dot j, and 0 correspond to I dot k cap with this entity. So using this entity we can say that E dot dr, our E dot dr is simply A by x cube dx. A by x cube dx. Now putting the value of this, let me just erase. So now putting the value of E dot dr in this integration, which is equal to 0 to space x, y, z. 0 to r contains x, y, z. So E dot dr is simply A by x cube dx. A by x cube dx. So this is And this is the definition minus infinity to at any point. We know the definition of electric potential. Electric potential at any point is how much work done by the force in bringing a unit charge from infinity to a point, reference point or point R. So this is the definition, basic definition of electric potential, which is mathematically expressed as E dot dr. Now putting the value of E dot dr from here and evaluating the integral. Now if you will evaluate this integral, which, so this is simply a power x minus 3 dx. So we know what is the integration of x power n. So x power n is, if you will integrate x power n with respect to dx, so what we will have? We will have x power n plus 1 divided by n plus 1. So we have a power minus 3 plus 1 divided by minus 3 plus 1 plus integration. So we have only integration in x, so this is infinity to x, and we have minus sign also. So what we have? We have simply minus 1 by 2, and minus minus will cancel out, and this is minus 2. So this minus will, this will give minus 2. Let me rewrite one more step, by minus 2. So this will cancel out, this minus minus will become plus, and we have a by 2x square, which is a scalar quantity, which is a is a constant, 2 is constant, x is any number. So this is, so the value of this potential V is simply a by 2x square. So this is very small questions that can be asked in any competitive examination. And what is the information? The information that we can extract from this question is twofold. First is, we can simply find out the unit and dimension of any constant. We can find out simply unit and dimension of any constant number, which is a. And another is, for a given profile of E, if we have a profile E which is in I cap direction, so we can deal the more complex situation with the help of this idea. We can deal more complex situation if we have a planar profile of electric field, if we have a 3D profile of electric field in Cartesian, in different coordinate system also. In this we have a electric field profile in only Cartesian coordinate system, but if we have a profile of electric field in Cartesian coordinate system, spherical polar coordinate system and cylindrical polar coordinate system, then we can also find out the length vector, because we have a profile of this dr. This dr is in, we can, if in this case our E is only in I cap, if our E is in I cap, j cap, k cap, then we have a complex expression and we can solve this complex expression also. So this is very simple but quite conceptual questions. So it's all about this. So we have, in the previous lecture we have solved the electric potential if the charge, if any point charge placed at the corner, and in this case if we have a profile for a given electric field profile, we can find out the simply potential for a given electric field. So it's all about this question. Thank you.